Thank you, Samantha. Good morning, good evening, as the case may be. Welcome to today's webinar. It's on database tips and tricks. Most of you are customers of Remedy. I think pretty much all of you are. And I'm hoping this presentation will help you, get better performance from your Remedy applications. My name is Rajiv Patel. I am a principal product developer. I've been with BMC for 17 years. I was with Oracle for almost 9 years before that. I've been in the software industry for, I think, close to 32, 33 years now. And whatever I've learned, especially about tuning Oracle and tuning SQL statements, has been invaluable in my job in Oracle and here at BMC. And I'm hoping to pass on some of that knowledge to all of you. So without further ado, let's set the presentation going. In between, if you have questions, I will be more than happy to answer them. But and also at the end of the presentation, we'll have a Q&A. So let's start the presentation. Today's agenda, loosely speaking, overview, caveat emptor. There's a performance tuning list that I basically adhere to, more or less. I have some tips about SQL Server. I have some tips about Oracle, and there's a bonus slide at the end. And some of these things are common. For example, parallelism, and especially parallelism. There's something that's common between SQL Server, Oracle, and even some other databases. But there are some Oracle-specific, tuning tips and parameters that greatly influence how SQL statements execute and behave in the database. And I'll introduce some of these to you. Some of these that I've used a lot over the past many years and have had customers see great improvements in their performance. So as far as BMC is concerned, our two big databases even today are Oracle and SQL Server. It used to be primarily Oracle with some, SQL Server customers, maybe when I joined Oracle 17 years ago. But there are more and more customers on SQL Server these days. And because of our move to Helix, where, we have customers on SQL Server all these years, Remedy on Demand and SaaS, they're moving to Oracle. So it looks like we will have more customers running on Oracle in the near future. And basically, a high percentage, I don't want to put numbers to a high percentage, but quite a few performance issues are encountered in the database when your SQL runs poorly, owing to either under-configured systems or suboptimal execution plans. And we can help these performance problems go away or become way less painful by addressing these, especially the tuning part of SQL statements. And certainly SQL tuning is extremely valuable when we're dealing with performance issues, especially those involving the optimizer coming up with not so optimal plans. And the best way to find out, obviously, is to look at the execution plan for SQL statements, either an estimated execution plan, which you can come up with in SQL Server and Oracle, and even in Postgres for the matter, or an actual execution plan where the SQL was running in the database. And obviously, like any database, configuration parameters can alleviate the problems. As I said, it could be missing parameters, or it could even be, parameters that were configured with suboptimal values. Caveat emptor, buyer beware. BMC is not in the business of database administration or SQL tuning. So all these tips are just that, tips, and not official BMC recommendations unless otherwise stated. Per se, we don't really have too many recommendations either for SQL Server or Oracle, but there are some parameters that we found over the years that basically, if they're set to their default values, they might adversely affect performance. So we've kind of made recommendations, and one of those is, for example, in Oracle, it's _B_tree_bitmap_plans. And I first discovered this parameter in 2005. And at different customer sites, I noticed that the default value, which is true out of the box, when it was set to true, it affected performance of SQL statements. So basically, one of the recommendations we have is to set it to false, and then evaluate your performance. If it does positively affect your performance, keep it set to false. And obviously, customer sites vary from the way they use the application to the amount of data they have, data skew, and so many other factors like physical sizes of the database servers, AR servers, et cetera. So basically, we're here to help, but that's not our primary business of tuning in the database, especially. And so the onus of doing so falls on the customer's AR team and the DBAs. So this is a loose performance tuning checklist that I've used over the years. If your database is SQL Server, a SQL profiler output, should point out high load SQL, and in that SQL profiler output, you can even select the actual execution plan, which SQL Server shows you the plan itself along with the values of the parameters, if there are any parameters or literal values, etc., in the SQL. Or I've seen DBAs use, direct SQL statements in SQL Server Management Studio, SSMS, SQL Server Management Studio. So it's another way to identify these slow queries. And basically, most DBAs do tend to have their set of scripts that they use to keep an eye on the database. And of course, there are third-party tools, graphical tools, like, in Oracle, you have Oracle Enterprise Manager. These tools also help you, identify queries graphically. Graphical outputs have way more impact, on the eyes, especially if you see something in the red, like CPU usage or memory usage. And you can quickly drill down to queries that are probably causing, that particular problem. Oracle has something called the AWR report, and it's valuable. It's a valuable tool. The narrower the time the report is generated in, the better you might have, better handle you might have on what's causing the problem. I've had customers send me reports spanning a day and a half, and 2 days. And so what happens is, something that was a problem for 5 or 10 minutes gets diluted and lost in such a report. So personally, I prefer a report that's maybe 15 minutes long. If users come in complaining about slowness in the system, I would, if I were the DB, I would take a snapshot right away, wait for 5-10 minutes, assuming the problem is persisting during that time, and then take a snapshot again 5, 10, or 15 minutes later, and then generate the report so that I can drill down on what's causing the problem. Basically, one of the things I do basically stress on when I'm dealing with customer issues is to make sure that it's only Remedy that's accessing your Remedy database, the production database, and you don't have reporting activities going on, because reporting activities can be resource intensive. And we usually ask our customers to move their reporting queries to a separate reporting database. That's basically a copy of production. If there are SQL statements for a high load, ask for the following, ask the DBA for the following execution plans, or if you don't have the expertise to read execution plans, have the DBA help you, generate and interpret the execution plans. Table row counts And the indexes and the columns that are indexed on those tables basically ask for optimizer statistics or optimizer statistics current. And if they're running Oracle in case sensitive or case insensitive mode, ask if you probably will know because the AR server config file, you will have configured it to run Oracle in case insensitive mode. And if it's case insensitive, ensure that the appropriate linguistic or function-based indexes have been created in the database. Again, this is a loose checklist. You might come up with your own list of questions to ask and things to look at. But this covers pretty much. Of course, one of the other things that you can ask for is, what is the CPU consumption on the AR server, the mid-tier, and especially on the database server, because it's likely that the problem is there. And is there enough memory? These are the things you might want to ask. If possible, one of the options that you might have to fix the issue might be, your machine is underconfigured, throw more memory, throw more CPU at it, and, it might just fix your problem. So these are the things that, you might want to, run down as a list and find out what it is that is leading to your problem. Let me start with SQL Server. We're going away from SQL Server. More and more customers are being migrated to Oracle, but there is still a fair portion of customers out there, running SQL Server on-prem. So it's important that I share whatever little I know about SQL Server. I've been working with the Oracle database software since 1989, doing performance work since, I suspect, 1990 or 91. And basically, that's how I joined BMC. I joined as a performance expert back in March of 2005. And when the more and more customers started moving to SQL Server, we had someone in the performance group who had experience with SQL Server, so he would handle those escalations. He left the company, I think, sometime in 2011 or 2012, and then I jumped into SQL Server, with my eyes closed. And I learned on the job, so I've had about 10 years of experience, and I feel pretty comfortable reading SQL Server execution plans these days. So the first one I'm going to talk about is maximum degree of parallelism, MDOP. So this is basically from SQL Server's own documentation. It's easier to set and run queries in parallel in SQL Server than it is in Oracle. Oracle involves a little more fiddling around with parameters. In SQL Server, at the instance level, you can actually set this parameter to a value, right? You can set it to 1, 0, or a number, any number all the way up, to apparently 32,767. So what SQL Server does is basically, based on one of the parameter, it will run the query in parallel or it will run it serially. Basically, if you want the SQL Server optimizer to use all the CPUs that you have available, set the value to 0. So if you have a 12 CPU machine, it's possible that the query will run, with 12 parallel slaves. Basically, if you want to suppress it, set the degree of parallelism to 1, which means you're telling the optimizer run this query serially. Now, if basically you have a 12 CPU machine and someone has set it to 16 or 20, it basically will use, it'll ignore it and use the number of CPUs you have available, which in this case would be 12 if you have a 12 CPU machine. The other parameter that influences parallelism in SQL Server is something called cost threshold for parallelism. So basically, this is a number. The default value is 5. So Microsoft still basically uses 5 out of the box. BMC over the years has come up with a recommendation. Again, this is a recommendation. It's 50. And you can experiment with that as a start and then go up and down depending on how the system is behaving, CPU usage, et cetera. But SQL Server will run the query in parallel if the value of the cost for that SQL statement is higher than the value set in cost threshold, and also if your maximum degree of parallelism is a value other than 1. It'll run the query in parallel. So basically, I have not introduced the term cost anywhere in this presentation, but loosely speaking, cost refers to how much it would cost the optimizer and the database engine to basically execute the query and give you your results. And costing, especially in Oracle, is something that you come up with using statistics. And so it's imperative that you gather statistics in your database, whether it's SQL Server or Oracle. And these statistics basically are gathered on indexes and tables, and even how many CPUs you have, how long it takes to read from disk. And for tables, for example, how many rows there are in the table, how many blocks, how many average number of rows per block, et cetera, et cetera, et cetera. Something called histograms also, basically from statistics, data distribution. If you have a table that has a column where, you have 1,000 values and 500 are John, 5 are Rajiv, and 7 are Samantha, you can note all this, generate histograms for that column so that the next time the SQL comes in with John, it knows that 50% of the values are John. Maybe I might use this way to access this data. If it comes with Rajiv, only 3 Rajiv, so maybe this index is a better way to go. So all of these go into figuring the cost of the query, and that cost now determines whether the query will run in parallel or not, obviously depending on the value of MDOP, should be anything other than 1. So again, 50 is a value that we recommend you start with and go up and down. I've seen customers running with values up to 200, more than 200. Definitely not 5, for sure. 5 is too low a value, maybe, especially given our remedy workload. And you might see a lot of queries running in parallel that really don't need to be run in parallel because serially they run almost equally fast. So again, comes with the warning that too low a value, closer to 5, might result in higher CPU usage. So as I said before, at the instance level on the left in this image, you can see that the instance is called CLM-AUS-017078. And I'm thankful to Doug for giving me this instance to work on. He gave it to me a few years ago, and I go back to it now and again when I have to do something with SQL Server. So, when you right click on that on properties, advanced, and, under advanced, you can see right in the bottom of this little box that's opened up cost threshold for parallelism, which for this instance is still the default value of 5, and the max degree of parallelism, the default value is 0. So that you can see over there, but I would certainly not recommend running with 0. You might, or running with 0 and cost threshold set to 5. You're probably asking for trouble. So I would recommend changing these values to, you can leave your, I wouldn't recommend leaving cost at 5, and certainly not MDOP at 0. I would come up with a value, especially if you have a lower environment like a dev or QA environment where you can experiment with almost a full load of your remedy applications. You might be able to come up with a more judiciously selected value for these 2 parameters, and then you can roll that into production and observe the system for a few days or a few weeks and make your choice of the appropriate values. Of course, these can also be set from SQL Server Management Studio, and your DBAs will look that up because I suspect the DBAs will be the ones who have the ability to do so. Over here too, I suspect it's the DBAs who might be able to do this, but I leave that up to you folks to decide who has the ability to do all this. So if you turn on parallelism and you have an execution plan, you will see parallelism reflected in the execution plan in a couple of places for sure. One in the actual operation itself, as you can see over here on the right, it says parallelism. And on the left, when you hover your cursor on the select, it'll show you degree of parallelism. In this case is 4. And another important point here to note is something called the estimated subtree cost. So the select statement, whether it's Oracle, Postgres, or SQL Server, a query, the query, the select, or the insert, or the update, or the delete, but especially the select, right? A select is composed of children, the children being the operations, an index seek or an index scan, et cetera, nested loops, a hash match, etc. These are the ones that are the children of that select, and the select statement itself is complete only when the children are all completed, right? So the estimated subtree cost for a SQL Server execution plan is nothing but the cost of the query, right? It's a total of all the costs of the individual operations that make up that select statement. These are the operations in this case being all these things on the screen that you see to the right of the select. The first one being the filter, the one after that being the top, et cetera, right? And so that subtree cost is basically nothing but the cost of the query. In this case, the cost is 117. And since parallelism is at play here, we know, for example, that the cost threshold for parallelism was definitely less than 117.301. And we also know that MDOP was definitely set to a value of at least 4, right? Probably 4. So that's good information you have just from reading an execution plan, top level. It ran in parallel, the cost was this, and you can assess the value of MDOP for that particular system. When you're either your own system or, as in my case, a customer's system. Something called keylookups in SQL Server. I've encountered this over the years. My experience with SQL Server tells me that if your keylookup is contributing an appreciable percentage to the cost of the query, it's something that you want to eliminate. So what does a keylookup do? A keylookup basically goes back to the table itself using the primary key. In this case, in the case of Remedy, a column C1, also known as a request ID for most tables, most forms in Remedy speak, is our primary key constraint. And what is a primary key constraint for a table? A primary key constraint for a table is a column that cannot be null and is unique, right? So we know that C1 cannot be null, C1 is unique. So when you have to go back to the table itself, after you've done some operation prior to the key lookup, it probably is because when you were doing that prior operation, in this case, on the right side, it's the index seek on a table T656. And just looking at the truncated name of it, the index is I656_0_400127440. Just from my experience, and probably from your own experience, you realize that that index, the first column in the index, is the column C40012744000, which in Remedy speak is the dataset ID. So we know that this thing is either coming from the CMDB side of Remedy or from the asset management side of Remedy, possibly even from maybe help desk or something where there's a tie-in to or linkage to, base element or something to retrieve the CI. So basically, the output of the key lookup, basically it had to go back to itself, to that same table, to fetch additional columns, which were probably in the select part of the query. So if you take those columns that are in the output list of the key lookup and you add them to the index, in this case, the I656 index, in the include part, the key lookup gets eliminated. Maybe the cost of the index seek goes from 48 to maybe 50%, but it certainly eliminates that 21% for sure. And if your query is running in 10 seconds, if you eliminate 21% of it, probably going to run in 7 or 8 seconds. Okay, that might not be a great improvement, but you've eliminated 2 seconds of, resource consumption on your database server. And the other thing that you see on the screen is that green thing on top that says missing index. Usually, if there is something that the the SQL optimizer, SQL tuning engine decides is an option, it comes up with a recommendation, including the possible impact on your query. In this case, this particular index has an impact of 13%. If that impact, once you create the index, if that impact percentage is realized, you possibly have a gain of 21 plus 13, maybe 34%, a third of the time. So your 10 seconds might become 6 or 7 seconds if you create the index and rerun the SQL itself. So the key lookup elimination, especially if it happens to be a large percentage of your cost, and I've seen key lookups. The next example I think is a better example maybe. Yep, that key lookup cost 48% of the entire cost of the query. So the same thing, if I eliminate this key lookup and add it to that index seek on the right, I might pretty much get rid of half the time it took, to run this query, potentially. So, if you can get an execution plan for the query from your DBA, and if you see a key lookup, you might not have enough experience reading the plan, but if you can get used to just looking for key lookups, if you can get rid of those, you're in good shape. There are two key lookups over here, the one I've pointed at and the one in the middle of the screen. That key lookup has a cost of 14%. So think about this: if you eliminate 62% of the cost of the query, you might gain back 62% of the time the query took to run potentially. If that query was running in 7 or 8 or 10 seconds, you're looking at 3 or 4 second stops, and that is a pretty good gain. It's a pretty good tuning exercise, I would say. Pat yourself on the back and go watch a movie or something. Okay, so what is that include I was talking about? Oracle doesn't have this feature. Postgres does. SQL Server has it, and it's a pretty awesome way of tuning your queries, especially as I mentioned before in the 2 slides before, eliminating key lookups. So let's say you have a query, something like this: select these 3 columns from T775, which usually happens to be base element, where the modified create date is greater than some number and the last modified date is greater than the same number. So I would create the index on these 2 columns in the predicate, aka the where clause. So I would create this index C3, C6, but the columns in the select part, the dataset ID, the class ID, and the C1 column, I would put that in the include section of that index. So basically columns that are, this is from the documentation, that are not part of the where or group by or order by, but only in the select clause, you can put them in your include section of the index, right? So they're sort of the lowest level of the index. They're not part of the, the leaf nodes, etc., but the lowest leaf. And these are not key columns, so they're sorted. They're not sorted when they're stored, right? So in this example that I've given you, this particular index that I've created is known as a covering index because the index itself satisfies the entire query. There is no need for the optimizer to go and look in the table to fetch any of the columns. All 5 columns are in the index. It's known as a covering index, right? And how do you do an include when your Dev Studio does not have the ability, Remedy's Dev Studio, which is where you would create your index from? We recommend you create the index in Dev Studio so that AR can have the information in its metadata tables, right? So you would create the index with the key columns. In this case, you would create the index on T775, on C3 and C6, and then it would generate a name, whatever the name is, system generated name from AR. Then you would ask your DBA to recreate the index with the include part in the index, right? Usually, if it's an include with just C3 columns, the DBA can do it through the graphical tool, right? But if it's got 7 or 8 or 10 columns, it's harder to select those columns in the graphical interface in SQL Server Management Studio, in which case the DBA would run, drop and create DDL, and then recreate the index with the same name. So that as far as AR is concerned, the key columns are there, the index is there, but as far as the database is concerned, which is where it's the most important to have those include in there, it has the include. Everyone's happy, AR is happy, the database is happy, and you're happy because the query is running better, right? So SQL Server statistics, set statistics, it's a really awesome tool. In SQL Server Management Studio, when you're tuning a SQL statement, issue the following commands: set statistics, IO, and time on. What that does is when you run the SQL, when you actually run the SQL, whether it takes 5 seconds or 50 seconds, at the end when it's run, after it's run, it brings back the rows. And I would recommend you select the actual execution plan before you run. So you're doing two things. In that SQL Server Management Studio session, you would set statistics IO, time on, execute this command, and comment it out. Paste your SQL in there. Select the actual execution plan from the GUI up there, one of the options up there, and run the query. At the end, after it's run, it brings back the rows, and then it has a tab in the lower end called messages, and another tab that says execution plan. Click on the messages, and this is the output you get. This is an actual output from the day before yesterday when I was working with a large customer, and we tuned their query. And basically, as you can see over here, it gives you awesome information. Basically, the amount of logical reads for the tables in question. As you can see, the scan count for table T598 right in the middle is close to 2 million, and the number of logical reads was 11.5 million. T62 and then T539, these are the big hitters. Of course, 596 and 686 were big too, but not compared to these three. And it gives you the execution time for that query, right? Something to note over here is the fact that your elapsed time for this query was 7.445 seconds. The CPU time was 41.344 seconds. So why is the CPU time greater than the elapsed time? The reason is this query ran in parallel. So it added up all the CPU times for the individual parallel query slaves. And so your CPU time is a multiple of your elapsed time. So this is certainly a great tool, because right away it tells you, if you look at messages, that 539, 598, and T62 are going to be, having a certain cost in your query execution plans. When you go there, you'll find that, okay, the cost is 5%, 10%, 20%, whatever the case may be. So then the aim would be to try and reduce that cost. The most important thing when you're tuning SQL statements, the most important piece of advice I can give you is when you're looking at an execution plan, whether it's Oracle, Postgres, or SQL Server, the first object that it accesses in the execution plan, if you can have better and better filtering conditions on that object, basically a better where clause, the predicate part of your query, you would get fewer rows coming back from that first object, and hopefully downstream, those fewer rows will persist and you will have your query run better. The fewer the rows that come back from your early tables, the better it is that your SQL will end up running usually, right? So, have better filtering conditions on your initial objects, and you might, have the SQL definitely run faster. Okay. So what does an AWR report collect? I'm going to go through this slide rather quickly. An AWR report, automatic workload repository report, collects a whole bunch of things, wait events, basically what your queries were waiting on, and it needs time statistics set to be set to true. And basically it shows you a lot of other things. The most important thing that usually is your resource intensive SQL statements, sections that talk about SQL sorted by elapsed time, physical reads, buffer gets, etc., etc. So bread and butter, start with that if you have to. If you need to, go back to your SQL statements, go back to that section, look at your SQL statements, and I'll have examples in the next few slides. And there are other sections that are invaluable: the ADDM, Automatic Database Diagnostic Monitor, and this thing is at the bottom of an AWR report. And usually, an AWR report, unless you have database privileges to the database server, your DBA will generate this report and pass it back to you. And you may not know how to read it, but my recommendation would be get an AWR report from your DBA. HTML1 is what I recommend. Go to the SQL section, and it'll show you SQL statements that are problem SQL statements. Start with the first section, elapsed time, and look at something called average execution time, right? That average execution time, I'll show you in the next slide, is key, because if it's a high number, each of those SQL statements has a link. So click on that link, and that takes you to the SQL statement itself. Take that SQL statement, send it to your DBA, and ask him or her to give you an execution plan or generate an execution plan, either the actual execution plan when the query ran in the database for which that AWR report was taken, during which time, or an estimated execution plan using something called explain plan. And if you have the ability to understand it, look at it and decide what the next steps are, or get your DBA to help you and decide if there's a possibility of creating an index or two to help the query run better. And this is something your DBA will do. You won't be able to do this, but you can basically change your settings to basically have the snapshots be created, held for 30 days, and how often the snapshot should be taken. By default, Oracle takes a snapshot every hour on the hour, and I believe the default is 7 days, but you can change it to any number you like. The DBA, not you, but I haven't seen very many customers change the default of 7 days of retention and 1 hour. In case you have to take a snapshot because suddenly you have a problem, and you ask your DBA, the DBA will run this command on top: execute dbms workload repository.create snapshot, wait for 10-15 minutes, take another snapshot, and then generate a report and send it back to you, since you've asked for it at the time when you're having a performance issue, your users are complaining. And then if you know how to read the report, as I said, go straight to the SQL section. It'll tell you what queries are running poorly, or sit with the DBA now and go through the report and try and see what was the reason your users are complaining, and then see if you can take care of it, right? The DBA is the one who basically will be doing all this, not you, unless you have access to the database, as I said. This is just for your knowledge. So what does that report show? The top part of the report, HTML report, shows you the actual clock time. In this case, the report was run for 7.39 minutes on the 24th of November, 2020, from 8:18 to 8:25. And the DB time was 11.71 minutes. The DB time is nothing but the total of CPU and wait times for all non-idle sessions. So it's a little bit more than your actual clock time, which usually is the case, right? This is the section I was talking about. These are the various sections: elapsed time, CPU time. The ones that I usually focus a lot on are elapsed time, which is the first one, and gets, which is buffer gets, memory reads. Reads is physical reads unoptimized, etc. The main ones are elapsed time, gets, and reads. So in this particular one, the example I've given you, what you have is the total elapsed time on the left, the number of executions, which is another important column, because as we know, up there, the report ran for 7 minutes, right? 7 minutes, 420 seconds. This first SQL over here, the elapsed time per execution, it ran 21 times in 7 minutes, right? It was 130 seconds, 2 minutes and 10 seconds per execution, right? And if it ran 21 times in 420 seconds, it was running once every 20 seconds, right? 21 times 20 is 420. On average, it took 2 minutes and 10 seconds to run. And another important column is a column right in the middle, percentage IO. 57% of that time, total time of 130 seconds was spent doing I/O. So I would focus on these queries, the 130 seconds, the one below that, 386 times in 7 minutes, an average of almost 7 seconds, right? And basically 99.5% pretty much spent all its time on the CPU. So that's a good thing. It wasn't doing I/O, would have been a little more resource intensive then. But these are the queries I would look at right away, 228 seconds for nine times. So I would go down this list, click on that thing under the column SQL ID. Those are links. SQL ID is nothing but a unique identifier for that SQL statement in the Oracle database. And so click on that link, it takes you to the actual query itself, copy the query, send it to and the SQL ID, send it to the DBA and ask for either an actual execution plan when it ran or an estimated one. And this is, again, usually you will have this, the plan table, but if you don't have it, you can ask your DBA to help you. But this is how you would create the plan table if it doesn't exist. And if you want to get an estimated execution plan, you would run the command explain plan for, either from Toad or dbeaver or SQL Plus. And then in order to see the execution plan, you would run the last query down there, select star from table dbms explain.display. So just simple explain plan basics. You don't really need to know this, but it might help. This is a simple SQL statement. The parent is the select statement on ID 0, and the next operation is the sort, followed by hash join, et cetera, et cetera, et cetera. So select is the parent. All of those IDs 1 through 7 are the children, so to speak, right? So Oracle documentation states that the first step to be executed is the most indented one that satisfies its parent steps requirement without any of its own children. If two statements have the same indentation, the one on top is executed first. So I'm going to go run through this slide. ID1 needs ID2 to be completed, which is a hash join. ID2 needs 4 and 5 because ID2 needs ID3 to be completed, right? 3 and 7 because 3 and 7 nested loops and table access full are at the same indentation level. So ID2 has 2 children, 3 and 7. 3 itself needs 4 and 5 to be completed because 4 and 5 are at the same level of indentation. 5 itself needs 6 to be completed, right? So basically, the order of execution would be number 4 gets executed first, right? 4 passes it back up to 3, which is a nested loop, right? Because 4 gets executed first only because even though 4 and 5 are at the same indentation level, 5 has a child, number 6. 4 is the first one that is the most indented that doesn't have its own child. So 4 gets executed first, passes it up back to 3. 3 goes back down to 5. 5 needs 6 to be completed. 3 completes, passes it back up to 2, which is a hash. And hash itself needs 7 to complete. So the order is 4, 3, 6, 5, 3, 2, 7, 2, 1. I'm going to rush through the slide, but you can examine this later after the presentation, and it'll make some sense. So you can go online or ask your DBA to explain this to you. But this is just something for your information in case you ever want to look at an execution plan and make some headway into taking up tuning on your own. Filters make awesome candidates for creating indexes. In this case, the most important thing to note is that the cost is $62,000. In the previous example, the cost was $266K, of which the most egregious operation was ID number 4, which was $244K. If you can get rid of that $244K and have that table access turned to something like an index, right, you would have gone a long way in tuning this query. It would take care of 90% of your cost, and the query will run faster. Oracle is estimating it to take 11 seconds. Maybe, maybe not. I don't really fully trust Oracle's estimated time. The cost, yes, not the estimated time. So in this case, the cost is $62,835 only because of the table access full. And down there, it tells you what it was doing. The query is on top. It's got 3 conditions in the where clause, 3 columns. And on the bottom, it's telling you that it does a full table scan. A full table scan is nothing but read every single row in the table and apply the filtering conditions from the where clause to find out if the row should be retained or discarded. And that's your filter down there. And so depending on these 3 columns, whichever is the most selective column, that becomes your first column of the index. The next selective becomes a second. The third selective becomes third column, right? And you've pretty much done tuning. If that index is picked up, the full table scan gets eliminated, and the cost goes down big time. It's estimating this thing to take 14 minutes. Oh boy, that's a long time. So it might go down from 14 minutes to maybe some seconds if the index is very selective. Basically, a parameter called session cached cursors, we recommend a value of 100. To make a long story short, this is again more for DBAs, but you can ask your DBA to look into this. Hard parses are where the database has to start from scratch, do a semantic check, a syntax check, and then a whole bunch of checks to find out if, to come up with an execution plan, looking at the costs, etc. That's a hard parse, and hard parses are very resource intensive. It takes a lot of CPU time, etc. You want to avoid hard parses. So if you can avoid a hard parse by making that SQL statement available for later executions of the query, you incur what is known as soft parse. Soft parses themselves are also somewhat expensive, though less than hard parses. So basically, if you set something called session cached cursors to 100, even a soft parse gets eliminated, because eventually, if that SQL is still in memory, if it's been executed more than 3 times, basically it's the SQL is there in the library cache, but what is stored is a pointer to the SQL, and the soft parse is also eliminated, because now the optimizer says, hey, there's a pointer here, and as long as the SQL is there in memory, it just goes and executes that SQL without doing anything at all. So that is a saving again, right? Because you're saving on latching, et cetera, in the database. So this is a good parameter to have. I have a customer that's recently set the value to 2000. I've never seen a customer set it that high. I've seen the customer, most customers use the recommendation of 100 and it works for them. So you start with 100 and go up and down depending on, usually up, depending on, whether it's effective or not. The other parameter that I've used over the years with a lot of success is something called optimizer index cost, ADJ. The default value is 100. It runs from 1 to 1,000. The closer you are to 1, the more likely the optimizer is to choose an index access over a full table scan. And I've had customers run with values of 1, 30, 50. A lot of customers just have the default 100. But when I introduce them to this parameter, especially if it helps their queries run faster, without incurring something like a SQL profile, et cetera, or SQL patch. More about this, you can get information about these other things from your DBA, from the web. They become more and more open to setting it to a lower value. With the caveat, though, that when you set it to a lower value at the database level, your SQL will certainly run better because you've decided this is the value for that query. But other queries will also not get affected, and they might start using indexes where maybe the full table scan was better because it was fetching maybe 70% of the rows in the table. Now it starts using an index and it goes south in a hurry. So it comes with a caveat that, test this out in your dev or QA environment, or lower value, and make sure it doesn't adversely affect the overall performance of your system. Just for the query itself, you don't want to sacrifice, the overall performance. This is the parameter that I was talking about earlier when there was a question about 12.201 optimizer features enabled, et cetera, et cetera. This is a parameter that Oracle has. It's a hidden parameter _fix_control. And I talked about the self join. in 12.101 or 11.204, it was using an index on both sides of the self join, but with 12.201, it used the full table scan on one side. So what this parameter does, for this query, what this parameter did, generally what fix control does is, Oracle has a fix. Let's say the fix is for bug number, as in this case, 118.14337. That was an Oracle bug number. So Oracle came up with a fix, and that fix was put into the code. But somehow later, Oracle finds out that that fix now is working for that particular case the bug was opened for, but it's not working for that other problem, some other SQL. So what Oracle does is, Oracle has a flag, :0, :1. If you set it to :1, so fix control equal to the bug number :1, you're saying, turn this feature on. In the code path, execute the fix that was put in for the bug. But if you set it to 0, you're turning off that code path. So in this case, in 12.201, the fix for that bug 118.14337 was causing a full table scan on one side. So when we turned off that fix, it worked beautifully. So Oracle had a couple of ways to make it use indexes on both sides, and this is one of the ways. So basically, if you encounter this thing in your, especially with HPD incident interface, you might want to set this at the database level, and it'll be fine. Okay, so as I said, opening up a service request with Oracle is a fantastic way to go, because they know their stuff more than anyone else, and they might help you with your problem by coming up with something like this or other underscore hidden parameters. Parallelism. I've been using this for the past few days for really, really recalcitrant, stubborn queries that refuse all other means of tuning. So in this particular example, this is a query from 2 or 3 days ago. This query was taking 30 or 40 seconds to run. It's basically a view. It was a view on basically 4 large tables, full table scan. Couldn't do much with this. So what I resorted to was, for this particular customer, I asked them to alter those 4 tables and set the parallel to 8, because this was I think it was a 48 CPU system. So we set the parallel to 8, and the full table scans were still there in the execution plan, but parallelism was at play here, and the query finished in 2 and 3 seconds, right? Now, this thing works at the table level only if your parallel degree policy parameter is set to manual, the default value. Don't set it to auto or something, especially if you're using this feature, alter table parallel. So make sure it's set to the default value of manual, and your query will run faster. I've used this for 3, 4 different customers and their queries, and it works like a charm. So that's something to keep in your back pocket if nothing else works for that query. This is a fantastic thing for you, especially if you're working with your DBA. You have a production system, and there is no way, during the day when your users are hammering away on your production system, that you can actually create an index and see if that index works or not, right? Oracle has this awesome feature called virtual indexes. So basically, you open up a SQL plus session or a dbeaver or a toad session, and you issue this alter session command in the middle, alter session set underscore, it's an underscore parameter, use no segment indexes to true. And you create so you're altering your session. It's only your session, right? Not your system. System level is at the database level. You're not doing that. You're only doing it in your session. So nobody else can see this parameter. Nobody else has access to your session. You're the only one. And you would create the index, whatever index it is, with this clause no segment. That no segment is very important. No segment means do not physically create an index. Only create it in my session's memory, in memory for my session. And then you take your query and you run an explain plan on it, right? and that explain plan runs. And if it picks up the index, if you compare it with the explain plan from before, if that index is indeed picked up and it's a good enough index, you will see a massive reduction in your cost, right? And that's a good thing, because then you can say, hey, I'm confident this index will really work when I actually create it in the database and implement it, right? So your DBA can now assess whether the index will be an effective one or not, and then you can take your decision to use it. I would recommend using it in a lower environment like QA dev, assess the impact, then roll it in production, right? Excellent, excellent, excellent thing for Oracle to have given us. So you can assess the impact of an index. But if you run the query in your SQL session, it will not see the index because it's not a physical index. It'll still use the old execution plan. This is only to generate an estimated plan using explain plan. So this is a great tool. Okay, I'm a little bit over the limit, but I have a bonus for you guys. This is something that I've been talking about for many years now. And the bonus is simply this. It involves your business as a business. It involves decisions you have to make at the business level, okay? So Remedy's AST, asset management views, are a join of the class's base table, whatever the class may be, computer system or software server or network port or whatever it is. It's a join with a view called AST base element. AST base element itself is a join of the BMC base element table with the AST attributes table. The AST attributes table stores attributes for the assets that are in your BMC base element table. And the join condition is where recon ID is equal to recon ID, base element recon equals AST attributes recon, or base element recon equals AST attributes instance ID. So the first part of the query, it shows you reconcile CIs, while the part after the OR, it shows you unreconciled CIs. If, as a business, you do not want your users to see unreconciled CIs, you can remove the OR condition in Dev Studio in the join part. Of course, you have to do this for each of your AST views that you want to tune, or you're seeing some performance impact on, because the OR condition can cause that query to slow down. Again, it's a business decision. Do you want to remove the OR condition functionally or not? So you can remove the OR condition if you don't want your users to see unreconciled CIs. I've had customers implement this and they've seen performance gains. So this is the end of today's presentation. I hope you gained something from it. If not, we can do this thing again until you get it. Back to you, Sam.